We're going to be talking about building progressive web apps. My name is Rene Rubalcava. I work on the JavaScript team. I am here today with two co-presenters. We got Andy Gutt, who is our product manager, and Luca over here, who you probably saw at the plenary, showing some really awesome 3D stuff. And we're going to be talking about building progressive web apps with the JavaScript API, which is, might find hard to believe, but you can do it. How many people here have tried building a progressive web app with the JavaScript API? All right, cool. So first off, let's talk about what a progressive web app is. This is kind of the agenda for what we're going to talk about. Some of the requirements to actually, not certify, but to call something a progressive web app. And then we'll get into building a progressive web app with the JavaScript API. Andy's going to talk about mobile web performance, and then Luca is going to kill it with some 3D performance tips, which are really cool. I learned some new stuff. So what is a PWA? So if you're familiar with it, sometimes you may go to use some app on your phone and you get some annoying notification that's like, do you want to add this app to your home screen? That means that the developers have set up that site to be a progressive web app, and that you can install that app to your home screen as an icon, and it gets run in a sandbox environment on the device. And it's kind of treated almost like a native app, not really quite like a native app. The cool part is you don't get the URL at the top, so you get a little bit more real estate with your application. That's kind of nice, right? So that's one of the things to get prompted to add it to the home screen, and there's some things that set that up. There's some things about with progressive web apps that are really cool, right? So some of the requirements is that they should have some smooth transitions. So if you have routing, for example, maybe your transition from one route to another might be this kind of like drawer effect, or just something that's not too jarring sometimes. It's not a complete requirement, but it's kind of nice if you can pull it off. I don't usually. Responsive. So responsive is a big thing, right? So the app should load, you should start being able to interact with it and do some really cool stuff. So fast loading is a requirement for a progressive web app. And then you get a native look and feel, right? So you can see here, this is a cool little app. This is a cool little game I used to play that on my phone a lot. But basically, you can kind of drag and drop different elements to create new elements, and you add new elements to that. It's just a really nice experience to play with it, because it kind of behaves like a native app. And that's kind of what you're shooting for when you're building progressive web apps, right? Just a really nice kind of interactive experience, which if you've seen with all this stuff that we have in the JavaScript API today, that we can kind of shoot for some of that stuff. So what are some PWA requirements? There is a acronym, PURPLE. You want to push critical resources as soon as possible to your application, render the page as fast as possible, and then pre-cache in your remaining assets. So you're going to get all the critical resources that you need for the page. Everything that, any JavaScript or CSS that is going to define what the page looks like right away should already be in the HTML of your file. And then anything needed after that, you can start pre-caching that. There's some, depending on the framework you use, and you're using a router, there are lots of times properties on that router you can say to start pre-fetching assets after the app is loaded. So they will load in the background, so when you go to a new page, they're already available and ready to go. And then lazy load parts of your application. So if you have an application that is going to have some sort of administration page, well, not every user is going to have an admin page because they might log in and get access to it later. You don't need to load the admin code right away, right? Or for a map, maybe you don't need to see the map right away. So don't load the code to create the map right away. Just get whatever you need on the page as soon as possible. That's going to be the critical resources that we have loaded here. So the JavaScript, CSS, and render it as quick as possible. Then we're going to pre-cache some assets. And once you've pre-cached those assets, now you can start lazy loading the bits you need after everything else is done. One of the ways you can do this is with service workers. So service workers are not to be confused with web workers. Not really. Right? There's things you can do with the web worker that you can't do with the service worker. Some of the same rules still apply. You don't have access to the DOM. You don't have access to a lot of globals like the location API, Some other APIs you don't have access to, but you have access to control the caching of network requests. So this question has come up before, and I get asked, so please don't ask me. This does not mean you can do offline with a PWA. It is not feasible, okay? Just don't have that much storage capacity to do it. But the purpose of the service workers is to cache your assets, things like your JavaScript, CSS, images, SVG, anything else like that can be cached inside the service worker. You can cache some calls to request so that they load immediately right away, and then they just kind of happen after the fact. There's different APIs with service workers, and I'll show you a little demo for one of those in a moment. But you have the notification API. This is that really annoying pop-up you'll get on some websites that says that this site wants to send you notifications. Gmail does it, which Gmail is kind of useful, but I don't need a ZDNet to send me notifications every time a new article pops up, right? And one thing to note with that too is that once you have told a site that you deny permission for something, it will never ask again until you go and you clear it from your browser to say that, let it ask me permission one more time. So that's their push notifications. So this is for pub sub capabilities. In the service worker, you can subscribe to some sort of like PubNub or some other pub sub service, and then you're going to get push notifications to the service worker that you can then send notifications to the browser for updates. So this is useful, like I said, something like with PubNub, if you have it, that maybe you are getting new work orders put into a system, and that gets pushed into your PubNub, pub subscribe service, and that can be used in your service workers, send that notification to the browser. Background sync, I don't use this one too often, but it's useful to ensure that if you send a request somewhere and you're offline, you can hold that request until you have a connection again, then you can make sure the data gets sent. It's a little tricky sometimes, but it does work. And channel messaging, this is kind of useful for communicating between tabs, iframes, and so forth inside the browser. It's similar to what you can do with the web workers for messaging. It's kind of cool. So let me end this slide here, and I'll just show you some notification stuff if everything cooperates. Okay. So I have this simple little app here, and if I run it, I should get a notification telling me that my, actually this is not the right one. Sorry. Let me come back to my browser. I was at the island helping people out with stuff, and I think this is the one I want. Here we go. So in here, I have an app where I am loading my service worker. And I'm actually not doing anything with the service worker. The service worker doesn't have anything in it. It's just an empty service worker. But I am going to be doing stuff with the service worker capabilities, the APIs of the service worker, right? So in my app, what I'm doing is I register my service worker. Let's make this bigger. I'm just going to go ahead and register my service worker. So if service worker navigator, that's how you kind of make sure you have service worker support. I do that. I register my service worker. So I've got a service worker object I'm going to save that to. And I have a function called request notification permission. So I'm going to ask for permission. All right, so I run the notification API, request permission. If I get permission, it should be granted. This could be denied, so you have to handle that. And I'll catch any errors. And then up here, I've got a method where I'm going to go ahead and, this first one. I'm going to query the number of features in the layer and just get that number. And I'm going to hold on to it for a moment. And then I have another method here where I have a set interval every 10 seconds. I'm going to check how many features are currently in that layer. And if they change, I'm going to send notification to my browser telling me that I've got new features in my layer. It's kind of silly, kind of dumb, but it's kind of cool. So I don't know what host I'm supposed to be on here. I'm going to guess it's 8081. It didn't. Oh, here it is. Localhost 8081. So yes, I'm going to allow notifications. And if I refresh now, I should get a first notification of the map view is ready. Oh, that didn't pop up. But this layer here is editable. Open my console just to make sure everything works right, because who knows what I'm doing. Oh yeah, so that works. I got my count. So now if I go to edit this layer here, I'm just going to go ahead and remove one of these, delete that incident, just give it a few seconds. Hope I did this right. I messed up my service worker. But you can see here I got one feature removed and everything. And this is because I know I was messing around with things over at the island trying to debug stuff for people. But that's the idea. I would get a notification popping up telling me that a record was removed or a record is added and so on. So that's kind of how the service workers work. And that's kind of a way you can do some cool stuff with the notification API inside of the service worker. So let's get back to my slides here. Same slide? All right, cool. So next part of building a PW is an Appshell. So an Appshell, for very simple explanation, is just the HTML that you want displayed right away. Right, and this is kind of cool. You may have noticed some websites that have this kind of, where there's going to be text, it's just kind of these gray blocks, and they have these kind of placeholder tags everywhere. That's an Appshell, because at some point they're going to fill in that content with real data. But just to get the application up and running, so you're not looking at a plain white page, you want to have something there available for the user to see, so they know that their internet's not broken or that the website's not broken, just that something's working. So it looks ready when the resources are going to load. This is useful if the actual UI of your Appshell is not going to change drastically when the data loads. So you don't want to use this Appshell and then display a map, right? I mean, it's not very intuitive. But maybe you want to put a globe sitting there. So someone looks at that and goes, oh, there's a globe on this page. I know that there will be a map showing up here at some point, right? Or maybe some sort of a grayscale map that looks like it's not real, but it kind of gives the idea that there will be a map there at some point, right? So the idea here is to separate the content from the navigation, okay? That's kind of where the Appshells come in. The next thing you need is a manifest. So it's called a manifest.json, and this is going to define how your app is going to behave as a home screen app. So you give it a name. This is going to be the application name that's going to be displayed on the home screen. Icons, so this is kind of a very, I shortened what the manifest would look like, but you actually would provide icons for about, I think like 6 different sizes, all the way up to 512 by 512 for Retina displays, right? So you're going to give all that. And there's information about the orientation. You can have color themes, so you can theme the browser color around it, what you want. It's really kind of cool, a way to do it. So how do you build progressive web apps with JavaScript API? I know that's the big question. So there's some considerations when you're building any mapping app. And that's just because mapping is hard. And there's a lot that we need to do when we're building mapping apps. So provide Appshell when possible. We already talked about this. Put a globe or some sort of picture, something to indicate there will be a map where there's going to be a map. And we'll talk about what happens when you don't have a map. Delay the loading of any code that's going to interact with the map as much as possible, right? So if you don't need a map right away, you're going to have some other UI, then who cares about having map code? Don't load it. Don't even load the JavaScript API until you need it, right? Maybe there's other stuff going on. And with the JavaScript API, these considerations come into play because the JavaScript API does a lot, and we have a lot of capabilities. So when we get a web map, for example, we pull the item information for the web map, what layers are part of the web map, what portals are used in the web map. So if you didn't know, yes, you can have multiple portals, items in a single web map. So we have to do multiple portal authentication stuff. We have to check for that. What are the capabilities of the services? Is your feature layer editable? Is it not editable? What kind of query capabilities does it have? Do your map services have multiple data sources and different information like that? We have to figure all that stuff out. Is it hosted or enterprise? And there are some differences between the services that we need to take consideration based on the version of server that you're using for enterprise services. And does your data need to be projected? right? So if you're not aware, you can give us a feature layer in any projection at all, and we'll reproject it to the base map projection. So we always need to take that consideration as well. So there is a lot that the API does, right? So just to give you an idea of some of the operational layers in the API, these are the list of operational layers that we have. And those are all the different layer considerations we need to take into play when you give us a web map, because we do not know what you've done. All right, so people ask us all the time, why the map kind of loads a little slow, what's going on? This is why, because we're so powerful and we do so much. So there's some patterns you can do, right? Determine the kind of pattern you want to do. I have a link here, they'll be in the slides when you get to them. This is the Android SDK. They have a very good page of documentation on map patterns and application patterns and how different considerations you want to do. Because they are a mobile native SDK, they've kind of taken all this into consideration. And I really liked it. It was a good resource to look at some stuff. And they have this idea of a mapless app. So the mapless app pattern dictates that the map is not the initial focus. Or any spatial stuff you're going to do, any kind of queries to data is all run in the background. You don't need to, maybe you have a list of information related to features that aren't being displayed, but you can still query a feature layer, pull that data in, run some statistics on it, and then display the information without a map, right? You can do that. This is an opportunity for you to delay loading the map. So I don't need to show it right away. Like I said before, who cares about the map code? And then if you have multiple pages in your application, you're going to be like, /map, /data, /list, /whatever. You can lazy load all of that code till you need it. And there are some other techniques with the frameworks you can do to do this stuff. So I have a demo, this nearby JavaScript app. This is an example app that is up on the developer site right now. And this uses the mapless app pattern. I'm going to go ahead and show you some of that today. And this took me like 3 months to do, mainly because I used React to do it, and React changed 3 times in 3 months while I worked on it. So yes, JavaScript moves very fast. So this other one I showed you with the service worker stuff, yes, that's React too, but let me close that one out. All right. So the way this application is actually structured is I have all the React stuff. So I've got components, I have context, I've got hooks, I've got custom hooks and everything for this application, right? It's a full-on React application. I have routes and pages and everything. But I have this data folder that I keep all the JavaScript API stuff in. So I have a file here that's going to create my feature layer. And in this particular application, it's not a feature service. It's going to be a feature collection. I'm going to be taking a result of some other query and then shoving those results into a feature layer because I want to take advantage of the renderer for it. I've got authentication, right? So this app does full-on authentication too. There's no React stuff in here. It's just all JavaScript API. And I have my map, and I've got some other stuff in here for directions and everything. But in this map part, I'm going to export a function called initialize. This function is going to take a DOM element, and then that DOM element is going to be attached to my map view. And that's going to make the map display, right? But I don't do that right away. I don't need it right away. And that's because if we look at my index here, there's a lot going on. Like I said, this is React. But I basically have my application provider, which is going to have my context, which if you saw our React session yesterday and Webpack stuff, context is kind of how you can do state management with React, right? So this is how I'm able to wrap my entire application state inside a single context. And I'm using a technique that React has called suspense. And suspense is a way that you can lazy load components until you need them. So there's more lazy loading. So not only am I lazy loading the JavaScript API, I'm lazy loading the components that even are going to lazy load the JavaScript API. So I've got layer upon layer of lazy loading things. It's probably a little much, but you know what? Why not? This is JavaScript. Have a good time. I do some stuff here where I check to see, am I on a desktop browser or am I on a device that I hope is a mobile device because you have a small screen. And I'm going to use routing on the small screen page. So that's where this router comes into play. And I have a list and I have a web map. If not, then I'll just show them both at the same time. And in this pages part, this is kind of where the lazy loading kind of happens. This is how you do lazy loading in React, and I won't go into detail. They make it very clear. It's a method called lazy, right? And you lazy load a component. But in my app context, like I said, the app context is where the state management happens. And this could be in any application. This applies to Vue, this applies to Angular, this applies to Dojo, this applies to Ember, or anything else you're working with. You just have an abstraction layer for the JavaScript API that's going to get lazy loaded at some point down the line. And that's what happens here. So when my application is ready to start and I go to that map page, I'm going to lazy load. So I do an await import. This is dynamic import. If you haven't seen this, it's available in Babel, which is modern JavaScript, as well as TypeScript. Lazy load that JavaScript, and then I could start doing things with my map. I have all these calls that are going to query the map, and they're going to zoom the map, and do all kinds of really fun stuff with the map. But at the end of the day, what I get is an application, if I've done this right, that looks like this. So this is how it would look on your phone. And you can actually put this on your phone today. And just to give you an idea of what's happening here, let me refresh it real quick. So this is not working, right? Let's do this. There we go. That's not the correct number of JavaScript files. Ah, I refreshed too fast. Okay. So I have an index file, and I have a bunch of these different bundles. And this is going to be just the code I need to get this nearby places list in my application. Now, it's pretty fast, right? And those results actually get cached, and I cache them manually in local storage so that when you start the app again, if you notice, I refresh, you'll immediately have the results available right here. But I'm going to go out and do a request. I get new results, and I'll re-update this again. So when I did this back in Redlands, I showed the restaurants that were out there right away, and then a couple seconds later, updated it with stuff in Palm Springs. It's a really cool technique, nice way to do things. So you have dummy data, or you save the data from the last request yourself, and then push it into your app, and it's ready to go. Now, I want to look at the map that's going to have all these places. If I click over here now, this icon will open the map. You see I'm now loading all the other JavaScript I need for the map to work, right? So I don't need all that JavaScript up front. I only load about 2 kilobytes of JavaScript to get my app running, which is pretty quick. And my audit score, it's a little low because of the Wi-Fi here. So if you're not familiar, Lighthouse audits is kind of a way you can, it's not 100%, it is not the source of all truth for your PWAs. Do not try to shoot for 100 across the board. But it's a good indicator of how well your PWA is going to perform. So my performance is 69, which if I tried loading everything up front, it would be like 8, right? And that's here. Back in the office, it gets like 81. I could cheat, which I did initially, and get 100. So when the app first starts and we do searching for these places, I use our locator task, which uses our geocoding API to search for points of interest. So that's part of the API, right? I could cheat by loading that in the worker and then have it run, so it doesn't block the main thread from doing anything right away. But the actual request still happened on the main thread. So it doesn't really make sense to do it. And I was real happy when I got 100%, and then my colleague pointed out that, I was just, he had a phrase I cannot repeat for it, but basically I was just messing around. It didn't make sense to really do it, which it was true, right? The only reason I get 81 as progressive web app score is that the way this app is set, my route, I don't have a home route, I have a list and a map route, so the redirects kind of screw up that score. But if I change list to home, I could get, that would be 100% on progressive web app score. And best practice is, again, 93. I only get dinged because I asked for to use the geolocation API when the app starts, which the Lighthouse will ding you on. But again, you might need that. So like I said, do not take these scores from the Lighthouse audits as like the source of all truth, and don't beat yourself up about it. It's just a good indicator of things you can improve. Although Lighthouse has some weird things, Lighthouse will tell you that, oh, your images are not being loaded as WebP, so you get a higher score if you provide WebP images, which I will tell you right now, If you want to have support for PNG and WebP at the same time, it's not easy because you have to have a little script in your HTML saying, does my browser support WebP? If it does, oh, let's use this CSS file instead of this other one. It sucks. It's a pain. And I think Firefox supports WebP now, but for the longest time, Chrome was the only one that supported WebP, and they still dinged your score for it. So you know what? Like I said, it's a Google tool. It's a useful tool, but it's not the 100% source of all truth. Use it as a guide, right? So that's kind of how you can build a PWA with the JavaScript API. That application's on GitHub. Take it, use it, abuse it, do what you want with it. Someone already told me they wanted to use it for some airport stuff. We also have some capabilities coming in the API to have a custom search sources for your search widget, which you can add in here if you want. There's a lot of cool stuff you can do with it. So with that, I'm going to hand it back to Andy here to talk about mobile web tips and tricks.
Thanks, Renee. Can you guys hear me okay in the back? Maybe a little louder. Can you hear me okay? So we want to just give you some pointers that apply to any web mobile applications, whether it's a PWA or just a plain old web mobile application. And there's 3 rules of thumb that you need to follow. Is that you might have already experienced this on your smartphone. Download speeds are slower when you're on a pure cellular internet connection. A lot of us have these powerful laptops and we're testing on our internal company Wi-Fi, which may be really fast. But when you get out there in the real world, the download speeds over cellular internet, they fluctuate. Even though your provider may say you have a 5G cellular internet service, that may not always be the case, especially as you move around town. So if you're building these applications for consumers or commercial for workers in the field, this is something to keep in mind. The other rule of thumb is there's significantly less processing power on your mobile device. Even though these things are amazing, modern mobile devices are powerful and fast, when it comes to the comparison of the rendering pipeline, the ability to display data and to process data on your phone, it's significantly less than your development laptop. And we're all doing our development directly on our laptops, so it's always a good idea to test on an actual mobile phone. The other rule of thumb is that performance hiccups are a lot more noticeable on a phone than your laptop. I mean, we've all used our phones and an application crashed, or there was a delay in an internet connection, and you start cursing about it because it's a smaller screen and it magnifies the problems. So between these 3 rule of thumbs, we encourage you to keep these in mind as you're building these applications on your awesome, powerful development desktop. So what do we mean when we say a performance hiccup? And the human mind is great at detecting that there's a problem with the user interface. 16 milliseconds. That's not very fast. I mean, that's extremely fast. And most things in the geospatial world take a lot longer than 16 milliseconds. So we typically assume a frame rate of about 60 frames per second, and we'll do a couple of demos that show you what we mean by 60 frames per second. But any delay in an operation in the user interface greater than 16 milliseconds, the research shows that you're going to be like, aha, I saw that. There was a slight delay there. So keep in mind, 16 milliseconds, it's a tough barrier to cross and a tough performance metric to meet. So how do we improve mobile performance? We have some tips for you. So map and data requests are usually slower over cellular. Like I was just saying, cellular internet is nowhere near as reliable as your hardline that you have at work or your Wi-Fi connection for your laptop. So downloading large amounts of data, it's just going to take time over cellular internet. And there's ways that you can test this in Chrome. Chrome has the ability to actually throttle back the network connection, and I'll show you an example of that. The other one is, on a mobile device, heavy processing on that main thread is going to have a greater slowdown effect on my iPhone than it is going to have on my laptop. It's just the way it is. It's just there's less processing power on that device, even though they're very powerful for what they do today. And when you're improving mobile performance, it's very easy to thrash the DOM of your application. What this means is, if you do anything that causes what we call a repaint, that causes the entire application to refresh from the very top of the view to the very bottom of the view, if you do that too many times, it's essentially going to cause one of those 16 millisecond, greater than 16 millisecond delays, and your end user is going to notice it, and they're going to perceive that as your app isn't very performant, something's wrong, or if it's severe enough, it could cause just a huge amount of frustration. So we have some recommendations. So we're going to recommend that you test using real-world scenarios. Take your phone outside the office, turn off your Wi-Fi, get out there and actually test your application on a device. Android, iPhone, iPad, whatever you have handy, borrow your coworkers' phones just to get some variation in what you're testing. I'll show you some examples of these. Lazy load, use fewer map layers, specify outfields, you want to simplify rendering, and you also want to use web workers. So I'm going to just walk through each of these and give you a more in-depth example. The nice thing about taking your phone outside is you can connect your phone to your laptop and debug it via a USB cable. So you're not just taking your phone outside the office and turning off your Wi-Fi, but you can also take your development laptop with you, and you can debug that application in real time so you can see what's going on. Highly recommend using this pattern. Lazy load. You don't have to load every one of the ArcGIS API for JavaScript modules up front. You don't have to have a giant require statement at the very top of your application. If you don't need access to certain functionality or certain types of layers, you can use this pattern right now inside your applications as a function. You can set the require statement and import the modules just like you normally would, but by removing this from your main require statement, you're deferring the loading of this particular class. So if you have a large application, you can save a considerable amount of time on that initial application load by deferring as much as possible using this pattern. Pretty cool, right?
So this technique is what, like what Andy has on the screen here, this is what you would do if you're using the CDN. So if they're using the CDN and you want a lazy load part, this is exactly how you would do it.
Yes, and you can do this multiple times in your application. Once that class or module has already been called using the require statement, it's cached in your application, so it won't trigger an additional download. You can also defer loading of layers. You don't have to load necessarily every layer depending on your requirements. So you can use this pattern called map add or map add many and load those layers at some point after the initial load of the application. And again, what we're working towards is that initial loading performance of your application. As Renee was saying earlier, you want to give the user a good impression on that initial load, and this is just another technique to move different functionality to later on in that workflow for that user to improve their initial experience. You should also use fewer layers. That means fewer layers means the application, of course, is going to load faster. It's going to use less memory in the application. Most modern phones have nowhere near as memory as your laptop. My laptop has 16 gigs. This phone has 4 gigs of RAM. So there's a significant difference. And plus, the browser itself has its own memory footprint. And every time you load a layer, it's if you've ever looked at the performance metrics in your browser, it increases how much memory your browser is using. And it also uses less GPU and CPU for parsing and rendering all these different layers. And one other trick that I also like to mention to developers that are adding layers in a lazy loaded fashion is you can also remove unloaded layer or unused layers. If you're not using a layer, you can use the map.remove method and go ahead and let that layer garbage collect, and that's just the best practice. And you should also be careful on outfields when you're making requests for your feature layers. You typically, in general, you want to avoid using the outfields equals star. And what that does is it will return the values for every field in that feature service that's being requested. In most cases, you only need to specify the particular outfields that you're using, like if you're using the name or the object ID in a pop-up.
Yeah, I got a little bit on this one. Let me lay it out for you on how this works now. So with the feature layer, the way the outfields works, you only really need to specify any fields in the outfields that you're going to use for the new filter function of the API, which you would have seen in plenary and you would have seen Jan talk about. If you have fields as part of your pop-up and fields defined in the renderer, we will automatically only request those fields needed. We won't request anything extra. But if you use a field in the filter that's not part of your renderer, not part of a pop-up template, then you need to add that to the outfield, or else we need to go back to the server and request all the data again to get the field with your data. So that's the one trick now. So you don't even have to bother with outfields if you don't need to. We figured out to optimize the request and make everything faster for you. So again, one of those things that we're doing with feature layer to optimize everything to make your life easier.
Thanks, Renee. You can also simplify rendering. Set the definition expression where possible. This reduces the number of features that are being pulled across the wire. So for example, I lost my cursor. There it is. So for example, here, all these different points, it's just returning as many features as is available in this extent. And what you can do on your feature layer is set the definition expression. I'll go ahead and rerun this and hope that I still have an internet connection. And you'll see there's a significant decrease in the number of features that are being displayed. But it's not just the display. If you look at the queries that are coming back, you can also see that that's only requesting the data that meets the definition expression. So it's significantly reducing how much data is coming across in the response payload. So definition expressions can be your friend if you don't need all of that data to come across the wire. And the last thing I'm going to mention before I turn it over to Raluca is use web workers where possible. If you have custom work that has heavy processing requirements, you can use web workers to move that off the thread. And I lost my cursor again. So web workers is an API, and you can access these web workers directly within your application. So a web worker is going to look something like this. This is a React app where it's what I could come up with on short notice is if you had to grab some data out of a custom database somewhere, we have a lot of customers that have requirements to use their own data. In this case, I'm just using a Geo JSON file to simulate that. But what this does is it's going out on a background thread. Lost my cursor again. It's going out on a background thread. It's fetching this data and doing this processing on the background thread, and then it's returning it to my main application. And to give you an example of how this can affect your application, in the top right of this screen, I'm just measuring the number of frames per second. There's a little bit of artifact there that shows 61 frames per second, which actually isn't possible in Chrome. But what I'm going to do is go ahead and add a feature layer to this application, and then I'm going to save it. And as this reloads, notice the frames per second rate drops as it's making that request and loading loading those points onto my map, which are the little blue and multicolored circles. I wanted to give you some visual indication that just because the application's doing something in the background and messing with the frames per second, you may not see anything, but if the user tries to do something with the user interface, like here it's going out and grabbing this file and parsing it, you can see that frame per second meter starts to drop as that's happening in the background. So my point is, and Raluca will also show you another example of this, if the user tried to do something during that time period when the frames per second dropped, they'd notice that the user interface wasn't as responsive. So we just want to get the point across to you that be aware these things do affect frames per second and do affect the user experience. The last couple demos I was going to show you is by outsourcing this functionality, you can actually improve application performance to the user. So here I have an example that is also going out and getting the same Geo JSON feed, but in the first example, I pre-ran it before this demo because time's short. This is going out and getting this Geo JSON feed and turning it into a heat map layer, and there's no web workers. It's doing all the work on the main thread, and it took 522 milliseconds. The next one is using a single web worker to do the same request, and it took 224 milliseconds to do the same operation. And then the last one is splitting this work up across 2 web workers to do the same amount of work, but it took 155 milliseconds. So by using these intermediate to advanced type pieces of functionality, you can dramatically improve your user interface performance. And with that, I'll turn it back to Raluca.
Awesome. Let's see if this works. Perfect. Can you switch it on for me? Thank you. So for the last 5 minutes, or how much do we have? I'm going to give you some tips and tricks for 3D. So as Rene said, mapping APIs do a lot of stuff in the background. 3D mapping APIs do even more stuff in the background. So you will have terrain, you will have 3D geometries, you will have symbols that are 3D. So here I'm just giving you some tips that you don't take them as Bible rules, like, oh, never put shadows on a mobile phone, but like, if you feel like your app is too slow, you might want to apply, like, check one of these things that I'm going to talk about now to figure out if it makes your app faster. So first thing, loading buildings. I have a simple tip here. It's about publishing scene layers with the latest version of ArcGIS Pro. Now I sound like a real marketing person. But the truth is that in this latest version, we publish scene layers using these oriented bounding boxes instead of spherical extents. And these are just much more performant. If you want to read about it in detail, Stefan wrote a blog post on how exactly it works and why they are more optimal. The second tip is that phones don't like heavy symbols. So in 2D, you mostly have, like, for points, I'm just taking the basic example here, points, you will have icons, right? So it's like an image, basically. In 3D, we have icons too. We call them flat symbols, and that's basically, oh, so one thing is, how do you measure symbol complexity? The number of vertices. So flat symbols, that would be like one vertex, and then you have one image that's fairly simple to display. It grows in complexity when you have symbols that become, like, for example, cubes. We call them volumetric symbols that have, the more vertices you have, the more complex it becomes, and the more time it takes to render. Phones also don't like heavy geometries, so consider generalization for lines that have way too many vertices that you don't need. The third tip would be to use tilt constraints. So when your camera is tilted so that you can see, like, the whole horizon, then we need to load a lot of tiles and a lot of terrain. And the more you look towards the, how to say, perpendicular to the map, then the less we need to load. And setting a max constraint on the tilt will not allow your user to go and look up in the sky, because they probably don't even need that, right? Another tip is in 3D you have set values, right, for the points. And there are several ways to visualize these points. You can have absolute heights where you pick the set value of your point if you have that. And if you don't, then there's also the mode like relative to ground, which we will compute, like we will make requests, queries to the elevation to figure out where your points need to be placed. And that takes up resources. So one thing that you might want to consider then is using absolute height, because then we get the set values for free and we don't have to compute anything. We have in the 3D API such a thing called low quality profile, which will make it faster in detriment of visual quality. So we change then, the map resolution will be lower, and we load lower levels of detail for scene layers. There's no anti-aliasing, but on the phone, I mean, the screen is so small that probably you won't even notice it. And then what I was mentioning before, calculating shadows is quite expensive. So in the image above, you see it with shadows, the building with shadows. In the image below, without shadows. And for a desktop experience, it's important to make it look realistic, but for a phone, maybe not that much. So it's, as I said, it's always up to you to consider, like, check it out with, without, and how it performs. And yeah, you might want to turn it off. And ambient occlusion is the way it helps for a more realistic visualization of the building. So here at the corners, you can see how it gets a bit darker to simulate the light, the ambient light. Again, up to you. That's maybe something that you don't really need on the phone, and it's pretty computationally intensive. I'm going to show you in an app after these tips. So demo time. Presenting live the FPS-o-meter in Palm Springs. So we built this app with having in mind that, like, these tips that I gave you, some are really costly and some not. So I put the ones that are that really drop the FPS rate down, and I'm going to show you a difference. So the first one is about the ambient occlusion. So like this lighting that you have on the buildings, you can see it over here. My current frame rate is 4, so now when I turn this one off, it goes a bit higher. Then I also have shadows on, so I'm going to turn off the shadows, and then it goes way higher. Like shadow mapping is quite expensive to compute. And then you can see these symbols that I have here for the trees. These are, this is exactly this symbol over here. And always, like, you can check on all these 3D modeling websites, you can check like the number of vertices. And you can see this model here has about 17,000. And then I went for a low poly one. Well, this might not really fit the style of your application, but just for the sake of the demo, this one has 700. And the moment I switch from one symbol to the other, then the frame rate goes up to 50 something. So this is, like I said, it's a couple of rules to keep in mind. They might actually make your web app faster. And this is all I had for you. Probably you folks are, I mean, I don't know how many of you are in 3D, so I kept it short. Another thing, oh right, another thing is, like, these are the phones that we support in 3D, because we released support for 3D only last year, like 1 year ago. So these are the ones that we actually tested on, and we can guarantee that it works on. And now question time.
Could you repeat the question?
Yeah, if you repeat the question on that one. So I got a bunch of samples I showed for PWA stuff was in React, and the question was, have I seen anyone use Angular or other frameworks to do that? I've used our internal framework that we use, our widget stuff, to do it before I load any map stuff. No one's shown me anything yet, but there's nothing saying it's not possible at all. And that's really the big thing that I've been pushing a lot recently too, is that whole abstraction layer of the API from your UI part of your applications. And there's a couple reasons for that. One is the whole PWA thing to kind of improve performance, lazy load the API as needed. The other is that what happens in a year from now when your shiny React application starts to show its age, maybe Angular or Dojo or something else is looking much better. It'll be much easier for you to rewrite the UI for your app and not have to worry about rewriting the JavaScript code because you didn't entangle all of your API code with everything else. So those are the other benefits as well to that.
Let me see the HDMI. Put me on 3.
You should be on 3.
I just want to show because I finally got that demo working. I was trying to show it to service workers. I can't let you guys walk away without seeing my cool demos. All right. So again, I showed this before. I have a service worker running that's going to tell me when my map is ready, then tell me when I delete layers and stuff. So here's my little thing. So please start. Don't tell me it's going to break again. I just literally just did it. So if I delete an incident, you know what? I give up. I swear this works.
Give Renee a big hand.
I swear. Thank you.